Welcome everyone. In this video lecture, we will solve a GATE 2024 EC question in which we will solve a problem based on 2x1 multiplexer. So the numerical is the propagation delay of the 2x1 mux shown in the circuit is 10 nanosecond. Consider the propagation delay of the inverter is 0 nanosecond, propagation delay for the inverter is 0 nanosecond, and propagation delay for the 2x1 mux is given 10 nanosecond. If S is set to 1, if the select line is 1, then the output Y is a square wave of frequency 100 MHz, a square wave of frequency 50 MHz. Option C is constant at 0, constant at 1. So this one is basically a problem based on 2 cross 1 Mach. So first of all, we have to know a simple basic idea behind the Mach. So what I am doing, a simple Mach diagram I am first making. Suppose this one is our 2 cross 1 mux. Okay, it may be rectangular shape, the shape, but okay, I am keeping this shape to it's 2 cross 1 mux. And if I am saying this one is 0 and 1, and if some select line is there and saying this one is D naught and D1, and it should be say Y. So this Y, if we have to write the characteristic equation for this mux, one can easily write d naught s bar plus d1 s. This one is the very important characteristic equation of a mux. Okay, clear? This one is the equation, means how it justify the mux operation. So for this purpose, we can write when select line is 0. Okay, when select line is 0, it will give d naught. So it should be y equals to d naught 0 bar, then d1 into s is 0, so it should be d naught. When s equals to 1, when s equals to 1, this should be 0, so y equals to d1. So this one is the equation for the mux. Okay, so now what we can do here, now from this figure we can easily say here we are getting y. Okay, and in this point we are getting y bar. Okay, y and y bar at 0 1. So the overall characteristic equation for this thing, what we can write, y into s bar plus y bar into s, just similar to this one. Okay, means this one is the equation. So this y equals to the simply y s bar, again I am writing the same thing, y bar into s. Okay, here d naught, now here the d naught, what I am writing, d naught is our y and d1 is our y bar. Okay, so this one is the important thing, important concept. So if you are able to write this thing, it will very easy. Okay, so characteristic equation for this circuit. Okay, y equals to y into s bar. Okay, so what we can write, characteristic equation will be y equals to y s bar. Every time I'm writing the same thing, but okay, y bar into s. Now in the question it is given if s is set to 1, if s equals to 1. Okay, so if s equals to 1, then y, that is our output, we can write this as a, also we can write this as a output, y output will be y s equals to 1, so it should be 0, so it should be simply y equals to y bar, or in general we can write y output 1 will be just the y bar. Okay, so what it results, this one is nothing but simply, if y is 0, y is 0, the output will be y is 0, means here it is 0, output will be 1. So and when it is 1, output will be 0. So this one is nothing but simply a square wave kind of thing. Okay, it will behave like this y equals to y bar. Okay, this y is the output. Okay, so now, so it must be our square wave kind of thing. Okay, for 0 it will give 1, for y 0 the output will be 1. Okay, like that it will. Okay, so now it is also given this is 10 nanosecond. The propagation delay of the mux is given 10 nanosecond. Propagation delay of the circuit is to correspond 10. When it is given 0 to 1, it will take 10 nanosecond. And again for the next one, 1 to 0 transition. Okay, 1 to 0, again it will take 10 nanosecond. So the overall period is here 10 plus 10. Okay, nanosecond, that is our 20 nanosecond. So the frequency of this square wave signal will be 1 by 20 nanosecond, or one can write 1 by 20 into 10 to power 9 hertz. Okay, so if we have to break, one can also write 10 to power 6 by 20. So it should be, okay, 6 is there and here 20. So 10 to power 6, and this should be, so 2 into 5, 0. So 50. So 50 into 10 to the power 6 means 50 megahertz. Okay. So frequency of the output will be at 50 megahertz, and this is nothing but simply a square wave of frequency 50 megahertz. So here it is important because the propagation delay for this period, it will take 10 nanosecond. For the another one, it will also take 10 nanosecond. So period is 20 nanosecond. So we have find the value of frequency by just f equals to 20 nanosecond. After simplification, we will get this one. So the correct answer will be our square wave of frequency 50 megahertz will be the answer for this question. Okay, so this one is a easy question, but the thing is that we have to know this some concept, or directly we can also do, but this characteristic equation is very important. Okay, this one is the basic. Okay, y equals to d naught s bar. So you have to know this concept, then you can proceed like this. So this is all about this question. So thank you for watching this video, and it is already given inverter at 0 nanosecond, so there is no worry about this inverter. So thank you for watching this video.